Every single year, American oyster farmers harvest over 1 billion oysters from coastal waters stretching from Maine to Louisiana, generating over $700 million in farm gate value for the U.S. economy. These remarkable filter-feeding mollusks not only represent one of the most sustainable forms of protein production on Earth, but also actively improve the marine environments where they grow. But how does a microscopic oyster larva become the premium shellfish that commands top dollar in upscale restaurants? Welcome to AgriCraft, where we explore the most innovative and sustainable practices in modern American agriculture and aquaculture. Today we are diving deep into one of the fastest growing sectors of marine farming. The journey from oyster hatchery to fine dining table involves cutting-edge marine agriculture technology and precision management. How do farmers create optimal growing conditions for these filter-feeding organisms? What happens inside those state-of-the-art processing facilities? And why are environmental scientists calling oyster farming one of the most important tools for restoring damaged coastal ecosystems? All will be revealed in this video. The story of oyster cultivation in America begins with Native American tribes who developed sophisticated harvesting techniques. These indigenous peoples understood the critical role oysters played in maintaining healthy coastal ecosystems. The transformation from traditional wild harvesting to modern industrial aquaculture is a success story of sustainable marine agriculture. The economic impact of American oyster farming has grown exponentially over the past 2 decades. This remarkable growth reflects both advancing technology and increasing consumer demand for sustainable seafood options. The United States now ranks among the top 5 oyster-producing nations worldwide, with operations spanning from the cold waters of Maine to the warm Gulf Coast estuaries of Louisiana and Texas. What makes oyster farming particularly fascinating from an agricultural perspective is the remarkable environmental benefits these operations provide. Unlike traditional livestock farming that often creates environmental challenges, oyster cultivation actually improves water quality and habitat conditions. A single adult oyster can filter up to 50 gallons of seawater per day, removing excess nutrients, sediments, and harmful bacteria that can damage coastal ecosystems. The biology of oysters is perfectly suited for sustainable aquaculture production. These filter-feeding bivalves require no external feed inputs, instead obtaining all necessary nutrition from plankton and organic particles naturally present in seawater. This means oyster farms have essentially zero feed conversion ratios, making them the most efficient protein production systems known to agriculture technology. Modern oyster farming operations combine traditional maritime knowledge with sophisticated marine engineering and biotechnology. The industry has evolved from simple bottom culture methods to complex 3-dimensional farming systems that maximize production while minimizing environmental impact. These advanced cultivation techniques allow farmers to produce premium oysters in areas previously unsuitable for shellfish production. The cultivation process begins in specialized hatcheries where oyster reproduction is carefully controlled and optimized. These facilities represent some of the most sophisticated examples of marine agriculture technology, using precisely controlled water systems, specialized feeding programs, and advanced genetic selection to produce millions of high-quality oyster larvae for farm operations. Broodstock selection in commercial hatcheries focuses on oysters with superior growth rates, disease resistance, and meat quality characteristics. Breeding programs have developed distinct oyster varieties adapted to specific growing regions and market preferences. These selective breeding efforts have resulted in oysters that grow faster, survive better, and produce more consistent market products than their wild counterparts. The spawning process in commercial hatcheries requires precise environmental control to trigger reproductive activity and ensure high fertilization rates. Water temperature, salinity, and chemical conditions are carefully adjusted to simulate optimal natural spawning conditions. Successful spawning events can produce millions of larvae from relatively small numbers of broodstock animals. Larval rearing represents one of the most technically demanding aspects of oyster farming, requiring specialized equipment and expertise that rivals any precision agriculture operation. The tiny free-swimming larvae must be maintained in carefully controlled tank systems with specific water quality parameters, proper nutrition, and protection from diseases and contaminants. The feeding programs used in larval rearing involve cultivating specific species of marine algae that provide optimal nutrition for developing oysters. These algae cultivation systems require sophisticated biotechnology equipment including specialized lighting, carbon dioxide injection, and nutrient management systems. The precision required in algae production and larval feeding demonstrates the high-technology nature of modern aquaculture operations. Settlement and spat production involve providing appropriate surfaces for oyster larvae to attach and begin their sessile adult phase. Commercial operations use various settlement materials including cultured shells, plastic materials, and specialized substrates designed to optimize spat survival and facilitate later handling. The timing and management of settlement is critical for achieving high survival rates and uniform growth. Nursery operations bridge the gap between hatchery production and grow-out farming, providing protected environments where young oysters can develop sufficient size and strength to survive in open water farming systems. These nursery facilities use upwelling systems, floating bags, and other specialized equipment to maintain optimal growing conditions while protecting vulnerable young oysters from predators and environmental stresses. The grow-out phase represents the main production component of oyster farming, where young oysters are placed in coastal waters and allowed to grow to market size over 12 to 36 months, depending on species and environmental conditions. This phase requires sophisticated site selection, equipment deployment, and ongoing management to optimize growth rates and product quality. Site selection for oyster farms requires detailed analysis of water quality, environmental conditions, and regulatory requirements. Optimal growing sites have appropriate salinity levels, adequate food supplies, suitable water depths, and protection from extreme weather conditions. Environmental monitoring ensures that farming sites maintain the water quality necessary for both oyster health and environmental protection. The farming equipment used in modern oyster cultivation includes floating bags, suspended long lines, bottom cages, and rack and bag systems. Each method has specific advantages for different environmental conditions and market requirements. The choice of farming method affects labor requirements, product quality, and overall farm economics. Environmental management throughout the growing period involves regular monitoring of water quality parameters including temperature, salinity, dissolved oxygen, and nutrient levels. Many farms use automated monitoring systems that provide real-time data on environmental conditions, allowing farmers to respond quickly to changing conditions that might affect oyster health or growth rates. Predator control represents a significant challenge in oyster farming, as numerous marine organisms prey on oysters at various life stages. Crabs, fish, rays, and birds can cause substantial losses if not properly managed. Protective measures include physical barriers, regular farm maintenance, and strategic timing of operations to minimize predator impacts. Farm maintenance involves regular inspection and cleaning of farming equipment, removal of fouling organisms, and adjustment of oyster stocking densities as animals grow. This ongoing management is essential for maintaining optimal growing conditions and preventing equipment failures that could result in crop losses. The harvest process for oysters varies significantly depending on farming method and market requirements. Some operations harvest oysters individually by hand, while others use mechanical systems that can process large quantities quickly. The timing of harvest is critical, as oysters must reach appropriate size and condition standards for their intended markets. Harvesting operations typically involve boats equipped with specialized lifting equipment for retrieving farming gear from the water. The oysters are then sorted and graded aboard the harvest vessel or transported to shore-based facilities for processing. Careful handling during harvest is essential for maintaining oyster quality and ensuring maximum survival during transportation. Quality assessment during harvest involves evaluating oyster size, shell condition, meat fill, and overall appearance. Premium market oysters must meet strict standards for uniformity, appearance, and meat quality. Lower-grade oysters may be directed to shucking operations or other markets with different quality requirements. Transportation from farming sites to processing facilities requires specialized boats and handling systems designed to maintain oyster quality during transit. Live oysters must be kept cool and moist while avoiding temperature fluctuations that could stress the animals. Proper handling during transportation is essential for maintaining the shelf life and quality that premium markets demand. Processing facilities for oysters range from simple sorting and packaging operations to sophisticated plants equipped with automated systems for cleaning, grading, and packaging. The level of processing depends on the intended market, with live shell stock requiring minimal processing while shucked oyster products require extensive handling and packaging equipment. The initial processing begins with thorough cleaning procedures that remove mud, debris, and fouling organisms from oyster shells. High-pressure washing systems and specialized brushing equipment clean shells while preserving the living oysters inside. This cleaning process is essential for both product presentation and food safety requirements. Grading and sorting systems separate oysters by size, quality, and market destination. Modern processing plants use combination of manual sorting and automated sizing equipment to achieve consistent product quality. Size uniformity is particularly important for restaurant markets where presentation and cooking consistency are critical factors. Quality inspection procedures in oyster processing facilities include detailed examination of shell condition, meat quality, and overall appearance. Trained inspectors evaluate each batch for compliance with market standards and food safety requirements. Only oysters meeting strict quality criteria advance to final packaging and distribution. Live oyster packaging requires specialized systems that maintain optimal humidity and temperature while allowing for proper air circulation. Traditional methods use breathable bags or containers that keep oysters alive during distribution, while newer packaging technologies extend shelf life and improve product presentation for retail markets. Temperature control throughout processing facilities is critical for maintaining oyster quality and food safety. Processing areas are maintained at controlled temperatures with multiple backup systems to prevent temperature fluctuations that could compromise product safety or reduce shelf life. Cold storage facilities maintain processed products until shipment to customers. Shucked oyster processing involves specialized equipment and procedures designed to efficiently remove oyster meat from shells while maintaining product quality and safety. Automated shucking systems can process thousands of oysters per hour, while manual shucking operations provide higher quality products for premium markets. The shucking process requires skilled workers using specialized knives and techniques to open oyster shells without damaging the delicate meat inside. Proper shucking technique preserves the natural shape and presentation of oyster meat while ensuring complete removal from the shell. This skilled labor represents a significant component of processing costs for shucked products. Automated systems and modern processing plants include conveyor belts that transport oysters through various processing stages, washing systems that clean shells and meat, and packaging equipment that maintains product quality while achieving efficient throughput. These systems combine traditional oyster handling knowledge with modern food processing technology. Packaging systems for shucked oysters use specialized containers and preservation methods that extend shelf life while maintaining product quality. Modified atmosphere packaging, vacuum packaging, and specialized containers protect delicate oyster meat during distribution. Proper packaging is essential for maintaining the fresh taste and texture that consumers expect from premium oyster products. The distribution network for processed oysters serves both domestic and international markets with sophisticated logistics systems designed for highly perishable seafood products. Specialized transportation maintains proper temperature and handling conditions throughout the supply chain, ensuring that oysters reach consumers in optimal condition. Cold chain management represents a critical component of oyster distribution, as these products must be maintained at specific temperatures to preserve quality and ensure food safety. Refrigerated trucks, air freight services, and specialized storage facilities work together to deliver fresh oysters to markets worldwide within hours or days of harvest. Export markets for American oysters continue to expand as international demand grows for premium seafood products. Asian markets particularly value American oyster quality and safety standards, while European markets appreciate the variety and consistency of American farmed oysters. These international markets often command premium prices that justify the additional logistics costs. The domestic market for oysters includes both restaurant and retail segments, each with specific requirements for product quality, packaging, and delivery. High-end restaurants demand premium oysters with specific size, flavor, and presentation characteristics, while retail markets require products with extended shelf life and consumer-friendly packaging. The nutritional profile of oysters makes them increasingly popular among health-conscious consumers seeking sustainable protein sources. Oysters are exceptionally rich in essential minerals including zinc, iron, copper, and selenium, while providing high-quality protein and beneficial omega-3 fatty acids. They are also naturally low in calories and saturated fat. Culinary applications for oysters continue to evolve as chefs discover new preparation methods and flavor combinations. Traditional raw consumption remains popular, but cooked applications including grilling, roasting, and incorporation into various dishes expand market opportunities. The unique flavor profile of different oyster varieties allows for sophisticated culinary applications. The sustainability benefits of oyster farming make it increasingly attractive to environmentally conscious consumers and investors. Oyster cultivation requires no external feed inputs, produces no waste products, and actually improves environmental conditions in farming areas. This environmental enhancement provides ecosystem services that extend far beyond the harvested product value. Environmental restoration through oyster farming has become an important component of coastal management programs. Large-scale oyster farming operations can significantly improve water quality in degraded coastal areas while providing economic opportunities for coastal communities. These dual benefits make oyster farming an important tool for sustainable coastal development. Carbon sequestration by oyster farms contributes to climate change mitigation efforts as oyster shells incorporate carbon dioxide from seawater into calcium carbonate structures. Large oyster populations can sequester substantial amounts of carbon while improving water quality and providing habitat for other marine species. Research and development in oyster farming continues to advance production techniques and expand market opportunities. Genetic research focuses on developing oyster varieties with improved growth rates, disease resistance, and flavor characteristics. Breeding programs are creating specialized varieties optimized for specific markets and environmental conditions. Technology advancement in oyster farming includes improved hatchery systems, more efficient farming equipment, and enhanced processing technologies. Automated monitoring systems reduce labor requirements while improving environmental management. Remote sensing and data analysis tools help farmers optimize production while minimizing environmental impact. The regulatory environment for oyster farming continues to evolve as authorities balance environmental protection with industry development. Water quality regulations ensure that farming operations maintain environmental standards, while food safety regulations protect consumer health. These regulatory frameworks provide the foundation for sustainable industry growth. International certification programs verify the sustainability and quality of American oyster products, facilitating access to premium export markets. These certifications provide consumers with assurance that oyster products meet strict environmental and quality standards while supporting sustainable aquaculture development. The economic impact of oyster farming extends beyond direct production to supporting industries including equipment manufacturing, transportation services, and restaurant sectors. This economic multiplier effect creates employment opportunities in coastal communities while diversifying local economies dependent on traditional fishing industries. Investment in oyster farming infrastructure continues to grow as investors recognize the combination of strong market demand, environmental benefits, and production efficiency that characterizes this industry. Venture capital, government programs, and industry investments are funding expansion of farming capacity and processing capabilities. Looking at the complete production cycle from hatchery to consumer, oyster farming represents an exceptional example of how sustainable aquaculture can provide both economic and environmental benefits. The precision required at every stage, from larval rearing through final processing, demonstrates the sophisticated technology and management practices that define modern marine agriculture. The transformation of oyster production from traditional wild harvesting to sophisticated aquaculture operations illustrates the potential for innovation to create sustainable food production systems that benefit both human communities and natural ecosystems. The industry's success reflects the integration of traditional knowledge with modern technology and scientific understanding. From those ancient Native American oyster management practices to today's high-technology hatcheries and processing facilities, the oyster industry exemplifies how agricultural innovation can create solutions that address multiple societal needs simultaneously. The environmental restoration capabilities of oyster farming make it unique among agricultural enterprises in providing ecosystem services while producing valuable food products. The coordination between hatcheries, farmers, processors, and markets in the oyster industry demonstrates the sophisticated supply chain management required for successful aquaculture operations. The quality standards maintained throughout the production process ensure that consumers receive consistently excellent products while farmers achieve maximum value from their investments. Thank you for joining us on this comprehensive exploration of one of America's most successful and sustainable aquaculture industries. The oyster farming sector demonstrates how innovative marine agriculture can simultaneously address food security, environmental restoration, and economic development challenges facing coastal communities worldwide. If you found this seafood documentary informative, please give this video a like and subscribe to AgriCraft for more investigations into the cutting-edge technologies and sustainable practices shaping the future of American agriculture and aquaculture. What other sustainable farming innovations would you like us to explore? Share your suggestions in the comments below and help us continue discovering the remarkable stories of modern agricultural innovation.